just to make certain that I also get it on the video, because I didn't get it on the video yesterday. I was trying to do it with 7th hour yesterday, but it didn't work quite well. So for those of you watching us on YouTube, you're watching 5th hour physical science today. And we are going over Unit 2.2 Worksheet 1. Okay, so starting us off here, number 1, discuss the physical meaning of the slope of the lines in this graph. What is the slope of the lines representing? Taylor? The density, yeah. So then from number 2, why did the data for metal 1 produce a graph with a different slope from the graph representing metal 2? So why are there different slopes? They're different types of metals, exactly. If it was all the same metal, what should I expect for a graph? Sorry, what? Yeah, same slope. So if they were all part of the same material, I'd only have one line instead of 2. So because I have 2 lines, that means I have 2 different metals. Number 3, what is the physical meaning of the vertical intercept of this graph? What's the meaning of it? In other words, the vertical intercept means where your line would cross the y-axis on your graph. So at what number is it crossing the y-axis? Mitch? 0, 0. 0, 0, yeah. So at that point, what's my mass? Nothing. What's my volume? Nothing. Yeah. So no mass, no volume. Do I have an object at no mass, no volume?
No.
Yeah, I don't have an object. So no mass, no volume, no object. Exactly. Number 4, use a reference source such as the internet or a textbook to find what elements the metals tested could be. So it's first of all telling you that our 2 objects are metals, and we want to find out which metals they are from their densities. Well, to start with, you could go about finding the density on here the old-fashioned way, but they give you a dead ringer for what the densities of these metals are. Where can you find that on here? Where does it say what the density is of each metal? Where does it say that? Take a look at that graph deal there. Take a look at all the information that's given to you there. It may not say density, but there's another word that is representative of density for this graph. That's in that information. Huh? No, that stands for correlation. Meaning like how good of a graph do the points make a line. So, what other information's on there that tells you this is density? Hmm? No. What's it say before that? What's it say before the CM3? By the way, I don't hear whispers very well, so it says volume. Is volume density? No. It's part of density, but it's not density itself. Okay. Slope, yeah. The slope of these lines are your density. Okay, I will emphasize again, if you do not have that note in your notes, please make sure that it gets there. The slope of these lines for the mass versus volume graph, again, if you see a graph where mass is your y-axis and volume is your x-axis, slope equals density. Okay? Slope equals density. So, those slope numbers that you have there, even though I know it doesn't say density, and I know it doesn't say grams over centimeters cubed, those are your densities of your two metals. Okay, so we've got metal 1. Metal 1 has a density of 7.78 grams over centimeters cubed. 7.78. Metal 2 has a density of 2.69 grams over centimeters cubed. So that's metal 1 and metal 2 in terms of their densities. Now, from what you guys found, what is 7.78 grams per centimeter cubed representing? What did you find for that one? Did anybody do this problem? You have a computer. I will give you 60 seconds. Use your computer and a quick find. Start. You can Google it up. 7.78 grams per centimeter cubed. Let's find out what it is. You got a computer. Go. Google. 60 seconds. Let's go. See if you find anything here, just raise your hand and let me know anything that you find. Taylor?
7,780 kilograms per meters cubed.
I'm looking for what kind of metal. I'm not looking for a number.
Sorry.
Yeah. So what metal do we have? What metal do we have? Okay, steel.
Aluminum.
I think, okay, for which one? Which one did you look up?
The second one.
The second one, okay. Aluminum. Okay, the first one, steel. Is there, because I know steel itself isn't an element on the periodic table, but does anyone know what steel is made from? Iron. Check out to see if iron is I believe it is, but.
On this,
Huh? It is? Okay. Yep.
also copper. I don't know.
Copper, I think, is a little bit different from that. Let's see what you find there. Thank you for bringing that. So pure copper is 8.96, so that would be about a 3%. Yep. So, good job, guys. And again, that's all you need to do for something like that is just do a quick Google search and bada bing, bada boom, find it just like that. So anyway, one more time recapping that problem. The slope for each respective metal represents its density. Okay, for what we're doing here, if you have a graph with mass on the y-axis, volume on the x-axis, you can find the density by finding the slope of the line. Okay, and that's where we got these numbers from. They actually gave you that information in that graph where they gave you the respective slopes. So we have iron and aluminum. Okay. Number 5 then. Suppose you have two materials of different densities. In the boxes below, draw a diagram of the atomic structures that could account for the differences in the densities of the two materials. Okay, so you have a box that is less dense and a box that is more dense. Okay, now, obviously you may hear me say this over and over, maybe you're tired of hearing me say it by now, but how is it again that I find density? Mass divided by volume, yep. Which is, of course, your slope of your mass versus volume graph, okay? Now, those two boxes there, what do you notice about the size of those two boxes? They're the same. So those two boxes, what do you suppose they're representing out of this? Are they representing mass, or are those boxes representing volume? They're not representing density right now, at least. What did we say mass was at the beginning of the unit? What is mass? Atoms. Yeah, number of atoms an object has. So in those boxes, we don't have any atoms drawn in, so that's where you have to draw in the atoms. So you need to take and draw like some circles or something to represent those atoms. So these boxes are representing volume. Okay? So if those two boxes, which represent volume, are the same size, what does that mean about our respective volumes here? They're the same. So we've got the same volume. Okay? The box on the left is less dense. Box on the right is more dense. Less dense, more dense. Okay, so if the volumes are the same, and we know we have to put atoms in both boxes, how should these two boxes compare? In other words, which box needs to have more atoms in order to be more dense? Which box needs to have less atoms? So which box needs more atoms, which box needs less?
The right needs more.
Danielle?
The right needs more.
Yeah, the right needs more atoms. If atoms are representing mass, and the volumes are the same, we need to have a bunch more atoms in our right box. And we'll need fewer atoms in our left-hand box. So for some of you guys, I saw you guys draw in the slope of the line, which was fine in terms of at least you have an understanding of what less dense and more dense are in terms of slope. I saw you guys having like a lesser sloped line for less dense, a greater sloped line for more dense. That's great in terms of slope, but in terms of representing it with atoms and volume, we want to make sure that we have more atoms in the right box, fewer atoms in the left box, because again, the two boxes are the same size volume. Okay, so if you need to take a moment and correct that, please go ahead and do it, because I'm actually going to go through something else quick in this next problem that'll take a few steps to do. Okay, so you might want to make sure you get like circles or dots drawn into your right-hand box and your left, with a few more on the right and a few less on the left. Now, in number 6, it asks, what is the density of this material? Now, in this one, they don't actually give you the numbers like they did on the first problem. So since I have a line, and of course I got numbers on each side of the line for mass and for volume that I can go about finding it, what do I have to do for that line to find the density?
2 points.
Chris?
Find 2 points in line.
Find 2 points in the line, then do what?
Subtract the first y, for second y, first
Yep.
y,
Yep,
second x, and first x.
yep. I gotta do y2 minus y1 divided by x2 minus x1. Which by doing that, when you're picking 2 points and doing that, you're finding the slope. Yep, so you're finding the slope of the line. So depending on how you did it, I personally got somewhere around 8 grams per centimeter cubed. 8 grams per centimeter cubed. If you got a little bigger number, in other words, like 8.5, 9, that's fine. If you got something more like 7 or 7.5, that's fine, somewhere in that slight range. But if you got something like 20 or 25, that's way too high. Or if you got something like 1 or 2, that's probably a little too low. Okay? So,
8 grams out of
one handy thing that you can do though with the graph, maybe even, you don't even have to necessarily pick points if you want to. What you could do also is you could create your own points. Say like if I wanted to do 80 grams, so I'll pick 80 grams as my second mass and 40 grams is my first mass. So 80 grams minus 40 grams. So what I got to do if I'm picking those numbers is I got to go 80 grams and then see where the line is at for the y-axis. I come across to where it meets my data line, my slope line, and then I come down to where it would meet the number for the x-axis. So 80, come across, down, that's roughly about 10. So I've got 80 grams and 10 centimeters cubed. For 40 grams when I do that, I come across here to the line again, 40, and then down, and I get roughly about 5, I think. And again, this is not perfect. You can do it much better if you take a ruler and do that, maybe a ruler and a pencil. You can draw maybe like slight lines to do that. It'll help you to match it up a little better. Again, this isn't perfect, but it gives you a rough idea. So then 80 minus 40 is 40 grams. 10 minus 5 gives me 5 centimeters cubed. 40 divided by 5 gives me 8. Okay? So if you didn't want to pick any of the points on here, you can always do that too. Again, just find a whole number, bring it across, and then come down and find roughly where it's at on the x-axis. Okay? So that's how you could do it to do your points there also. Last one then. So we have this first equation, d equals m over v. And I know a few of you had some difficulty with this problem, so you might want to have, if you don't have your notes up, you might want to have it up, because I'm going to give you a couple suggestions for how to attack this problem. Okay? So that's our first original equation that we had. Now, number 7 asks you, what would be the volume of a 200-gram sample of this material? Well, a couple different things you can do. Number 1, if you're good with your math skills and you can rearrange this simple algebraic equation, awesome, great. All you have to know is this equation, and you can do that. But if you don't know how to rearrange, you're going to want to get all 3 equations down, and yeah, you might have to do a little memorizing. Okay? So, follow me through on this. I'm going to do 3 different colors, so that way I can represent the equations and how you rearrange. Right now, D is on its own. Okay? Let's say if I want to find the mass, which I know problem 7 does say I want to find volume, but let's say instead I wanted to find the mass. How can I rearrange this equation to solve for M? Any initial thoughts on how I can solve it for M? So M is by itself, Dylan?
Multiply each side by v.
Multiply each side by V.
Correct.
Okay, so I multiply both sides by V. Okay, so that way what happens is that V here is in both the numerator and the denominator, and they cancel one another out. And then obviously V then appears on the other side. So now my second equation reads volume times density equals mass. So volume times density equals mass. So now my third equation, which will help us to answer number 7, because number 7 asks for the volume, and I want to get volume by itself. So right now, volume and density are tied together by multiplication. How can I undo that?
Divide each side by density.
Correct, divide each side by density. So then I get equation 3, which is volume equals mass divided by density. So volume equals mass divided by density. That's my third equation. One other thing I want to show you too is how the units cancel out to make this happen. Okay, we already know in here that density equals mass divided by volume, so that gives us a unit of grams over centimeters cubed for volume. I'm sorry, not volume, units of density. Grams divided by centimeters cubed. In here, volume times density, so I've got centimeters cubed, or milliliters for that matter, times grams over centimeters cubed. When I've got grams over centimeters cubed, and I'm multiplying by centimeters cubed, just like in here, V's cancel out, centimeters cubed cancel out. So when I take volume times density, my centimeters cubed cancel each other out, and I'm left with a unit of grams, which is my unit of mass. And the last one here, when I take mass divided by density, I'm taking grams divided by a gram over a centimeter cubed. When I do a gram divided by a gram, the grams cancel each other out, and I'm left with 1 over a centimeter cubed. Which, when that happens, it's like taking on your calculator and doing 1 divided by 1 divided by 4. 1 divided by, in other words, 1 divided by 1/4. Well, 1 divided by 1/4, and you can try this in your calculator, should give you 4. 1 divided by 1/4 gives you 4. So 1 divided by 1 over a centimeter cubed will give you a centimeter cubed, which is the unit of volume. Okay? So just wanted to show you there how units cancel out to make this happen. So if you're not good with being able to rearrange equations, then you'll want to make sure you have all 3 of them down to want to know. Okay? But if you're pretty good at rearranging equations, all you need to know is this first one. Okay. So, getting back to the last question in number 7, what would be the volume of a 200-gram sample of this material? Well, means I've got this down here already, I'm just gonna use what I already have since I've rearranged it to do that anyway. So volume is gonna equal mass divided by my density. So 200 grams divided by my density, which I'm gonna use the density for my last problem. So I calculated 8 grams per centimeter cubed. So 200 divided by 8 gives me 25. Grams cancel out, centimeters cubed. Now, if you had something like 7 or 7.5 as a density, that means your volume here is going to be a little bit higher than that. Or if you used a number like 8.5 or 9, your number might be a little bit lower than that. Obviously, that's within the ballpark depending on how you did number 6. Okay? All right, so from all that, does anyone have any questions about the assignment? Okay. And again, if you need this, make sure that you jot that down for your own notes. Okay, now as I realize I've only got about 14 or so minutes left, here's what I'm going to do. Originally I was going to start a lab today. We're not going to start that until Monday. What you are going to be working on is an assignment that I sent out. I think I sent it out first period today to first hour. Obviously it should have gotten all to you guys too. It is 2.2 Worksheet 2. It is a lot more specifically dealing with density problems, where literally you're going to be using all these 3 equations to do that. So again, maybe you might want to jot that down on your worksheet too, so that way you have it. Brady, please put your chair down. Okay? What we'll do on Monday is I'll start first with questions that you have in class over the assignment if you're having some trouble with it, and I'll give you until Tuesday to get it completely finished. That way you can come in on Monday and ask some questions over things that you're having trouble with. But obviously if you come in on Monday not having done a single problem and expect me to do every single problem with you, that's not going to happen. Okay? I'm not going to sit down and go through every single problem. Again, the assignment will be due Tuesday, so I'll do it then. So your responsibility over the weekend is to work on this worksheet and get it mostly done. That way, if you've got questions that you can't figure out, bring them to class on Monday. I'll help you get through some of those difficult ones on Monday, and we'll go on and do our lab. Now, one quick thing for the viewers on YouTube, since we didn't quite get to the results from, well, I think we got to the results. I wasn't able to record them from the other classes. Again, just a quick brief explanation for the camera. Remember you had a graduated cylinder. Let's say I'll use this as my graduated cylinder, my water bottle, where you had to find the volume of your you had to find the volume in centimeters cubed and the volume in milliliters. You picked 5 different marks on your graduated cylinder, and you wrote down what the volumes were in milliliters, and then you had to calculate the volumes in centimeters cubed. Just a quick recap with volume. How was it again that we were able to calculate the volume of that graduated cylinder? What did we have to do with the ruler? What were we doing with the ruler itself? What were we measuring?
Moving side to side, not
How about when I was measuring up this way? What component of volume was I measuring? Well, with the ruler, what component was I measuring there? Centimeters. In other words, of the formula for this, the up and down, what's that representing? If I'm measuring how tall someone is, what's that saying about them? Height. Yep. So I was measuring the height for the ruler. because I was finding where the mark was at that you were choosing, and you were measuring the height with that, okay? What's that other component that you gotta take height times to get volume in centimeters cubed? I'm sorry, the area, okay. How do I find the area of a circle? How was that again?
Pi times radius squared.
Pi times radius squared, yep. So you're doing pi r squared times the height to get those 5 different volumes. So obviously, you had 5 different heights to measure from milliliters. So, all in all, what did we find out about a milliliter and a centimeter cubed? What did we find out? They are the same, yep. So those 2 units of volume are equal to one another. A milliliter equals a centimeter cubed. All right, that's a wrap. Go ahead, last 10 minutes, work on your worksheet, start to get going on that. I'm going to stop the camera, and I'll start to answer other questions after that, okay?